Welcome to tonight's video on the rate word problems. We'll start off by talking about a spherically shaped balloon. I should say shaped, not shared. Shaped balloon is being inflated so that the radius is changing at a rate of 5 inches per second. And it says find a algebraic representation for the volume as a function of time. Well, remember, the volume of a sphere is equal to 4/3 pi r cubed. And this here is saying the radius is changing at a rate of 5 inches per second, so 5t. Right? It starts out at 0, and then it goes plus 5t. So you're adding 5 inches per second. So when we talk about the volume of the sphere as it relates to time, it's going to be 4/3 pi times 5t cubed, because the radius is 5t. So that is our algebraic representation. Determine the volume after 8 seconds, solving graphically. So remember, we have our volume is equal to 4/3 pi times 5t cubed. So that is going to be our y sub 1 is equal to 4/3. So we're going to have to go 4/3 like that. And then pi, and then in parentheses 5x to the third. Now, when we type that in our calculator, it looks something like this. So we go parenthesis 4 divided by 3, close it. Then you have the pi, which is right there. And then you have parenthesis 5x. And then that goes to the third power. So that's how you would want to type it in. Then for your window, well, you'll see, remember, we're talking about the volume of a sphere with relation to time. So 0 is going to be the minimum. And then for the volume, the y minimum will be 0. Let's make the y maximum, because we don't know what the volume is. Let's try 1,000, see what happens. So when we graph it, notice that we don't get what it is, because if we go for trace after 8 seconds, notice it doesn't show us. So let's see if we can extend our window more for the y. And let's go to 500,000. So notice now 8 seconds is out here. Notice now it shows up. So our window is, domain is 0 to 10. The range, the range is from 0 to about 500,000. And you just keep playing with it. Now, you have this picture here, and we'll see the graph. Notice it starts out like this and just goes up. Now, to find when after 8 seconds, remember 8 seconds is an x, we're going to go trace 8, enter. So we'll do that here. We'll go trace 8 and then enter, and it gives us 268,082.57. 82.57, and that's cubic inches, and that is the volume after 8 seconds of the sphere. All right. So looking at the next problem talks about a metal ball with a radius of 2.7 centimeters, and that's placed into a tank of sulfuric acid. And the radius is going to decrease at a rate of 0.0053 centimeters per second. So the radius starts out as 2.7 centimeters, but then it gets smaller by 0.0053 centimeters per second. So that's our radius. It says find an algebraic representation for the surface area as a function of time. Well, remember, surface area of a sphere is 4 pi r squared. So basically here, the surface area over time is equal to 4 times pi times 2.7 minus 0.0053 t squared. So that's our algebraic representation. When will it be completely dissolved? That means when will the surface area be 0? So basically we have 4 pi times 2.7 minus 0.0053 t squared equal to 0. Solving graphically, our y sub 1 is 4 pi times 2.7 minus 0.0053 x, or t in this case, squared. And then our y sub 2 is going to equal 0. So let's go ahead and clear this, and we'll go 4 second function pi times 2.7 minus 0.0053 x parentheses squared, and then y sub 2 is 0. Now, what we have to think about here is what would be our maximum for x? Well, let's look at the window when we graph it. Notice nothing shows up there. So let's start thinking about, okay, if t was equal to 0, that would mean that I'd have 4 pi times 2.7 squared. Well, 4 pi times 2.7 squared is equal approximately 91.6 if you do that in your calculator. That means that the maximum that I can have for y in my range, my domain is going to be something, but my range, the maximum I can have is 92. Because when the time is 0, the maximum that it will be is 92. And remember, it's going down, so that's why my range is 92, the max. So now that we can put that in, change this to 92, and look at the graph. Well, notice we see it there, and then, but it's not crossing the x-axis. So we got to change our window. We'll try like 500. And notice it's starting to go down there. And notice it does cross the x-axis there. So basically, let's see just a little more just to see. Let's do 1,000. And notice it goes down, and then it's going to go back up. Right? Well, remember that it's going to completely dissolve. So we want to know when it's 0, because it's never going to go back up. So you're going to start out with a certain amount, and then notice it's just going to dissolve until you got 0. So basically, we'll stick with our original of 500. So notice that gives us a good idea that the surface area of the sphere just stops right there. That's when it's dissolved. So now if we just hit second trace, intersect, enter, 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 it's thinking about it. Oh, and it quit on us because it said no sign change, which means our window is too small. So let's make it 800. Just so it's a little bigger. Even though we don't need this part out here, just so it's a little bigger, it'll give us our answer. Because basically it was saying that the answer is not in the range. So we do that again. Second trace, intersect, enter, enter, enter. And notice we get 509.43396 seconds. We'll just make it 509.434 seconds. So that's how long it'll take until it's completely dissolved. All right, so the next question uses a lot of geometry. It says Tom is 5'6" tall and walks at a rate of 3 feet per second away from a street lamp with its lamp 10 feet 8 inches above level ground. So here is our street lamp with a little light there. That's not what I wanted. All right, then here's Tom. And he's walking away from the street lamp. So here's the street lamp. Tom's walking away. And then his shadow is going to keep getting bigger, or his shadow is going to keep getting smaller as he walks further away from the light. So what you want to figure out is what is the length of his shadow as it relates to the time after he walked away from the shadow or from the light. So basically the distance from the street lamp, he starts out 3 feet away. I mean, basically he goes 3 feet per second away from the street lamp. So his distance, he starts out even with the street lamp, and he's now 3 feet per second. So basically it's 3t. Now we're going to use geometry here by setting up similar triangles. So we have one triangle with the street lamp, and then here's Tom. All right, now the street lamp is 10 feet 8 inches. When we change that into feet, it'll just be 10 2/3, because 8 inches is equal to 2/3 of a foot, which as a fraction is 32/3. So the street lamp is 32/3. Tom is 5 feet 6 inches, which is 5 1/2 feet, which is 11/2 as a fraction. So Tom here is 11/2. Now the distance that he travels is 3t away from the street lamp. And this is the length of his shadow, L. So L is going to be the length of his shadow. So when we want to write an equation, we use similar triangles. So basically, in this big triangle here, we have 32/3 over 3t plus L, because 3t plus L is the length of this whole side of the big triangle. And then in the smaller triangle, notice we just have 11 halves and then L. So when you cross multiply, you get 32 thirds L equals 11 halves times 3t plus L. Because remember, when you have a ratio, you cross multiply. Now, remember, your goal here is to solve it for L. You want L equals as a function of time. So what you're going to do is distribute first. And we're going to go into the next problem here. So 32 thirds L equals 33 over 2t plus 11 halves L. Then remember, we're going to multiply to get rid of the fractions. And you guessed it, we're going to multiply by 6. So when we do that, 3 goes into 6 twice, so it's 64L equals, and then 2 goes into 6 3 times 33 is 99t, and then 3, so plus 33L. Then you subtract minus 33L, so you get 31L equals 99t, and then when you divide by 31, you get L equals 99 over 31t. So that is your equation for L. L is equal to 99 over 31t. Now it says find the length of the shadow after 16.4 seconds. Well, remember, L is equal to 99 over 31t, so that's your y sub 1. 99 over 31x. Put that in your calculator. We got to remember to put parentheses around the 99 over 31. Like that. We do not have a y sub 2 in here because 16.4 is an x value, and we're trying to find the y sub 2. So now our window will go from 0 to, let's say, about 20, because we got realistically in time to get away from the shadow of his, to get away from the street lamp, it's going to take him about 20 seconds or so. And then the length of his shadow, we'll just guess probably about 100 and see what happens when we graph it. Notice there it is. We have a little graph like this that's a line. So it goes like that. And then remember to find after 16.4 seconds, we go trace 16.4, hit enter, and notice you get 52.374. That is the length of his shadow, 52.3742 inches. That's the length of his shadow after 16.4 seconds. All right, I hope you enjoyed the word problems, and we'll talk about them more in class. Make sure you study for your quiz that's coming up, and have a good weekend.